So independent events are events that can stand alone. They can be by themselves. They don't affect the outcomes of other things. So keywords are replacing, if you see the word replace, or toss a coin, those are independent, or spin a spinner, or if you're rolling a dice. So how to calculate, so if you have the probability of A then B, you do the probability of A and multiply it by the probability of B. So example 1, find each probability below. You toss a coin twice. Find the probability of getting 2 heads. So this would be the probability of getting heads, then the probability of getting heads. So you're going to do the probability of getting heads on a coin is 1/2 because you can either get heads or tails. So it's going to be 1/2 times 1/2, which is 1/4. Next example, you roll a number cube dice once, then you roll it again. What is the probability that you get a 2 on the first roll and a number greater than 4 on the second roll? So I'm going to do what's the probability you get a 2, which is 1 out of 6, because on a dice there's 1 through 6, times a number greater than 4 is 2 out of 6, because these two are greater than 4. So 1/6 times 2/6 is 2/36, which is 1/18. And then I'm going to skip this one because we're talking about playing cards. I'll skip that one. Okay, dependent events cannot stand alone. So the key word is not replacing. Not replace. So how to calculate? You do the probability of A times the probability of B after A happened. So what I like to do is I like to write out, if you have 3 girls, make 3 G's. And 2 boys volunteer to represent their class at a school assembly. The teacher selects one name and then another name containing the 5 students' names. So if you're picking volunteers, you're not putting the volunteer names back, but they're going to be gone. So both girls would be, what's the probability you get a girl, which is 3 out of 5, and then pretend that one of these girls are gone. So now it's going to be 2 out of 4. This is going to be 6/20, which is 3/10. What is the probability that the teacher chooses a boy than a girl? So probability of a boy is 2/5. Now one of these boys is gone. Now what's the probability of getting a girl? It's 3/4. So it's 6/20, which is 3/10. What is the probability that teacher chooses a girl then a boy? So chooses a girl, which is 3 out of 5, and then a boy, so a girl is gone, which is 2 out of 4, which is 6/20 or 3/10. Are the events described below independent or dependent? A guest at a party takes a sandwich from a tray. A second guest takes a sandwich. This would be dependent because one sandwich is gone, so it's dependent. Sam flips a coin. Flipping a coin is independent. If you flip a coin and get heads, if you flip a coin again, you could still get heads. That's why it's independent. Examples down here. A shelf holds 3 novels, N, 2 biographies, and 1 history book. what is the probability, oops, I'm going to make B for biography. What is the probability they're both novels, but replaces it? So this is when the fractions don't go down. So both novels would be, probability of novel is 3/6 times 3/6, or 1/2 times 1/2 is 1/4 when you reduce it. Probability of a history is 1/6, then a novel is 3/6. So it's 3 out of 36, which reduces to 1/12. What's the probability they're both biographies? So 2/6 times 2/6 is 4 out of 36, which is 1/9. What's the probability they're both history books? Is 1/6 times 1/6, which is 1 out of 36. So the word both means biography, then biography. This means history book, then history book. Both means two. Okay, 2 puppies are chosen at random from a box at a mall. What is the probability of each outcome? So you have these dogs. There are 12 dogs. So when you pick up a puppy, you don't put it back. You're taking the puppy. You're not putting it back. So it's called not replacing. So these fractions are going to go down because you're not replacing. So what's the probability you have 2 blacks? So there are 9 black puppies. One of them is gone, so there's 8 black puppies left. And you're going to reduce this fraction. You're going to take out one of the black dogs. You're going to have 11 dogs left. What's the probability they're both brown? Well, there's 3 out of 12 are brown. So you take 1 brown away. So you're going to have 2 brown dogs left out of 11. And you multiply across. What's the probability you have a setter, which is 4 out of 12, then a hound? So you take 11, and then there's going to be 3 hounds left. Multiply straight across and reduce. What's the probability of a retriever? There's 5 retrievers, then a setter. Well, there's going to be 11 dogs left, and there's still 4 setters left, and then you reduce. So make sure you reduce your fractions.